Hello everyone, welcome to Mechanical Sati. So today in this video we'll be continuing our lecture series which we started for thermodynamics. So here we are discussing some probable numericals for GATE 2021. So already we have uploaded three videos. So in those we have discussed three important questions. So if you have not watched those, then go to the playlist of thermodynamics and do find them and watch them before watching this. So here we are taking a question and discuss the concepts whatever used in those. So we'll be discussing another important question over here. So without wasting time, let us move forward and start our discussion. So here we have taken another question. So let us first try to read it. So a system executes that is quasi-static process from an initial state 1 to final state 2. Okay, observing 80 kilojoule of heat. Okay, so during that process, when a quasi-static process is being done, okay, from state 1 to state 2, heat is being observed. That amount of heat is given is 80 kilojoule, and expanding from 2 meter cube to 2.25 meter cube against a constant pressure which is given as 2 bar. Okay, so volume expansion or expansion is done from 2 meter cube to 2.25 meter cube, and during that our pressure is remaining constant. So the system is brought back to its initial state by a non-quasi-static process. So this is the important thing over here. So after going from state 1 to state 2, again our system is coming back to our state 1, and during that whatever process or whatever in which path it is coming back, that process is not a quasi-static process, that is a non-quasi-static process. So do remember that. And during which it rejects 120 kilojoule of heat. Okay, so during that non-quasi-static process, it is rejecting 120 kilojoule of heat. So we need to find out the work done in the second process. Okay, so what is the work done during that second process? That means that non-quasi-static process, we need to find out that. Okay, so let us try to first draw the process diagram over here. So for drawing any process diagram, so we have to draw the property diagram. We have to draw two properties. So let me use pressure and volume over here, because here pressure and volume is known to us in both the states actually. So okay, so let us try to draw it. So let me draw pressure in y-axis and volume in x-axis. So it will be okay. So in this we will be taking the pressure, and in this we will be taking the volume. So volume in terms of meter cube, okay, and pressure it is given in terms of bar. Okay, so this is in terms of bar. Okay, so this is a constant pressure process, so I can draw a line like this. So let me use another ink over here. Okay, so this is our process, and this is the state point 1 and this is the state point 2. At this point let us assume our pressure, we can say this is as our 2 bar. Okay, so at this pressure only when our process is occurring. Okay, and let us try to show the volume over here. So let this volume which is given to us as 2 meter cube, and this volume which is given to us as 2.25 meter cube. So this is 2 meter cube, okay, and this is 2.25 meter cube. Okay, so these are the data which is given to us, and Q absorption during when our process is going from 1 to 2. So in this process our Q is given as what that is 80 kilojoule. Okay, and it is again returning back to initial state, that which is given to us as 1, and by which process it is coming back, that is a non-quasi-static process. So we can show that process by a dotted line. So let me use another ink so that it will be clearer to you. So it is coming back to this initial state by this process, by the black line which I have shown you. So by using dotted line we have we are using to show the non-quasi-static processes. So it is asking to find out the work done in the second process, that is work done in the non-quasi-static process. So we have to find out that only. And what are the else data are given. So another data here, it is given that the heat rejection during 2 to 1, that is during that non-quasi-static process. So let me write it as 1 to 2, and Q 2 1 it is given to us, that is 120 kilojoule. Okay, so these are the some data which are given to us. Okay, so in this case, that means let me use the pointer. Okay, so in this quasi-static process, it is given that it is a constant pressure process. So isobaric process we can assume. Okay, so this is a constant process and quasi-static process, and it will be trying to find out the work done. So first let us use our first law of thermodynamics. So according to first law of thermodynamics, so let me write it over here. Okay, sorry. According to first law of TD, we can write what, that is dq will be equal to, so let me write it in this way, that is q will be equal to dE plus W. Okay, so the net heat interaction will be equal to the change in internal energy, or the change in energy plus the net work interaction. Okay, so here you will see Q is given to us. So in this process, that is from 1 to 2 process, heat interaction it is given to us as 80 kilojoule. And if we'll be trying to find out the work interaction, that is W12. So let me use the pen. Okay, so W12 we can calculate over here, because it is we can assume this is as a closed system and it is a quasi-static process and pressure is remaining constant. So simply it will be using this relation 1 to 2 state it is P dP, and we can find out it as a P into V2 minus V1. Okay, so simply putting the values what are given to us. So pressure is given as 2 bar over here, and volume V1 is given 2 meter cube, and V2 is given 2.25 meter cube. So from here we can calculate the W12. So W12 we can calculate. So this value will be getting, so let me check. So W12 we are getting as okay, so I have not calculated, so try to calculate by yourself. So let me write it over here. So Q is given to us as 80 kilojoule, and what is given during that process, where did it go? Okay, so Q observed during 1 to 2 process, it is being observed to the system, so we can take Q as the positive. Okay, so we will be putting, so in this 1 to 2 process, I can write Q12 will be equal to dE. So here dE I can write as E2 minus E1, okay, plus W12. Okay, so here E2 minus E1 I can calculate. So E2 minus E1, so that means we have to take this work into this side. So it will be equal to what? That will be 80 minus this W12. So W12 we can calculate. So the 2 into 10 square into 2.25 minus 2. Okay, so simply if we will be calculating this value, we will be getting as 30 kilojoule. So E2 minus E1, that is change in total energy, will be getting as 30 kilojoule over here. Okay, so now for 2 to 1 process, so let us go to previous slide. Okay, so now from 2 to 1 will be going by rejecting 120 kilojoule of heat. Okay, and we need to find out what is the work done during this process. Okay, and we know the value of E2 minus E1, that is the internal energy, that is the change in internal energy, as internal energy, sorry, that is we have taken here total energy. So in case of your quasi-static process and closed system, we can assume there is no any other energy, that is there is no velocity, so there is no kinetic energy, and there is no head, so there is no potential energy. So we can assume that here dE, so dE we can assume as du also. Okay, so there is no problem for that. Okay, so now by rejecting 120 kilojoule of heat, what is the work done during that second process, we need to calculate. Okay, so dE is known to us, that is E2 minus E1 is known to us. So for 2 to 1 process, our internal energy change will be equal to what? E1 minus E2. So we know the value of okay, E2 minus E1 we know, and that's how we can calculate the value of E1 minus E2, and that will be equal to simply negative 30 kilojoule. So students are making mistake over here, that they are assuming that change in internal energy in this process, that is from 1 to 2, will be equal to change in internal energy during 2 to 1 process. So that is being done in all maximum of the students make this mistake in exam. So this magnitude will be equal, but the direction will be different, that we have to use another negative sign over there. Okay, so during 2 to 1 process, the change in total energy or energy will be equal to what? That is minus 30 kilojoule. And heat interaction, it is given as 120 kilojoule. So simply we can calculate the value of work interaction, that is the net work done during 2 to 1 process, and that will be equal to what? So let me write it over here. So W2 to 1 we can calculate as, that will be equal to Q to 1. Okay, so Q to 1 minus E1 minus E2. Okay, and Q to 1, it is given that it is being rejected. So it is being rejected from the system, that means we have to take it as negative. So we can write it over here. So let me use pen. Okay, so that will be equal to what? Minus 120 kilojoule minus of, this is minus again, so that is minus 30 kilojoule. Okay, so it will give us the answer, that will be equal to minus 90 kilojoule. So this is the work interaction during our process, that is the non-quasi-static process, which is being asked in this question. So this will be the correct answer for this question. Okay, so I think you have understood this one. So if you have understood this one with any doubt, so if you have any doubt, you can post in the comment section. And if you have understood it clearly, then do press on the like button, which will give us some motivation to make some more videos on this. So do share it with your friends who needs it. Okay, so keep smiling, be safe. So thank you for watching.